Okay, so let's talk a little bit about how drill connects to various different data sources. And so the drill's internal architecture includes an execution engine, which is kind of the main, that's really what actually runs the processing. And the execution engine takes advantage of these libraries called storage plugin or storage plugins. So there's a file storage plugin for talking to distributed or any file system actually. There's a MongoDB storage plugin for talking to a MongoDB cluster, an HBase plugin, and then a Hive plugin for talking to communicating with Hive deployments. So let's talk a little bit about the file plugin first, because that plugin is pretty unique. It actually, when talking to or when querying data off of a file system, the data can be in a variety of different file formats. And so Drill supports various different formats out of the box, and you can also add your own formats. So Drill has support for CSV and Parquet and JSON and Avro and actually all kind of text delimited files here. And then, of course, you can add your own formats with what we call a format plugin. And then Drill also has support for a variety of different file systems. So that would be some things like the local file system on Linux, Mac, Windows. It could be an HDFS or a MapRFS cluster. It could be Amazon S3, Google Cloud storage. It could be Azure Blob Storage, an NFS-mounted share. And you can add any additional plugins here to support additional file systems. And Drill can actually communicate with multiple different storage or data sources from a single Drill cluster and even do joins across these in a single query. So let's look at an example here. Let's say I had a collection of JSON log files in one of these file systems. And so, one record may look something like this. There's the timestamp, there's an additional dictionary here that's called details, and then there's a message. Okay, so that's one single record in that JSON log file. And then maybe I have an entire directory of these files that are getting produced by my application servers. And so if I write a simple SQL statement to query that data, and notice that I didn't have to set up any schemas or any metadata, I just point to that directory as part of the table name, and I can query that data. And so in this case, we're doing a select message, comma count from, and then DFS happens to be the name of this specific file plugin instance, and /logs is the directory that we're querying. So Drill is going to look at every file inside that directory, and based on the extension of that file, it will know what type. And so in this case, let's assume these are JSON files, and we're going to group by message. And basically, in this case, we're producing a count of how many occurrences of each message in the log files in that directory. And so if we wanted to query data in, let's say, MongoDB, even let's assume that it has the same kind of structure, all we would have to do is, instead of here calling the table dfs.root and referring to a path in the file system, we would actually do something like from MongoDB dot database name dot collection. So let's say logs. And now we're querying a collection within a MongoDB cluster. And so that's basically what you have to do in order to query data. And Drill under the hood is actually leveraging these storage plugins. In the case of Hive, you can see that we actually have a more traditional relational data model. There's actually tables, and the schema is known up front to the system, which is very different from a case like MongoDB or JSON files, where there actually isn't any schema that's known, and Drill can't actually know what the structure of the data is until it's actually read the data.